Mars, often imagined as humanity's next great frontier, presents a hidden and potentially deadly challenge that could jeopardize any future human mission: toxic dust. While the inhospitable climate, radiation exposure, and psychological isolation of a Mars mission have long been discussed, the danger posed by Martian dust may be even more insidious. Recent research warns that exposure to this dust could cause severe and potentially irreversible health effects for astronauts, raising serious doubts about whether long-term human survival on Mars is truly possible. Martian dust is not just a nuisance. It is a toxic, omnipresent threat. Unlike dust on Earth, which is gradually smoothed down by wind and water over time, the dust on Mars is sharp and jagged, making it far more dangerous when inhaled. Microscopic particles of silica, gypsum, nanophase iron oxides, and perchlorates make up the fine dust that coats the Martian surface and atmosphere. These substances pose multiple risks. Silica can cause severe lung diseases. Iron oxides may contribute to long-term pulmonary damage, and perchlorates, which have been detected at toxic levels, can interfere with thyroid function and blood cell production. Once inhaled, these particles do not simply settle harmlessly in the respiratory system. They can become embedded in lung tissue, causing inflammation, scarring, and potentially life-threatening conditions similar to those seen in workers exposed to asbestos. Unlike the Moon, where astronauts were able to deal with lunar dust as a short-term irritant, a Mars mission would involve prolonged exposure. The fine particles could work their way into spacesuits, habitats, and even the astronauts' bodies over months or years, leading to cumulative damage. The study highlights a particularly concerning scenario. Astronauts already face an increased risk of pulmonary fibrosis due to space radiation. The combination of radiation damage and the inhalation of toxic dust could accelerate lung disease, leaving astronauts with permanently compromised respiratory function long before their mission is completed. Given the long travel time between Earth and Mars, taking at least 6 months each way, there would be no possibility of emergency evacuation. Any astronaut suffering from severe lung inflammation or respiratory failure would be forced to endure it without access to the advanced medical care available on Earth. Even if astronauts could avoid direct inhalation of the dust, it would still pose a serious challenge to mission sustainability. The dust is constantly settling, coating every surface, and forming thick layers across equipment and solar panels. NASA's robotic rovers have already encountered this problem. Several have lost functionality as dust buildup blocked their ability to charge their batteries. Human missions would require constant maintenance and cleaning just to keep essential equipment operational. Unlike Earth, where rain and wind naturally cleared dust away, Mars has no such mechanisms. Instead, dust storms, some of which can cover the entire planet, ensure that no surface remains untouched. The need for continuous dust removal would place an immense burden on astronauts, consuming valuable time and energy that could otherwise be spent on exploration and scientific research. Engineers have proposed various solutions to mitigate dust exposure, from electrostatic repulsion devices to advanced filtration systems. However, these measures present their own challenges. Filtration systems, for example, would require regular maintenance and replacement, meaning that astronauts would need to bring a massive stockpile of spare filters, adding to the already daunting logistical challenge of transporting enough supplies for a multi-year mission. Any failure in these systems could result in a slow but unavoidable buildup of toxic dust inside the habitat, leading to chronic exposure that would eventually become life-threatening. Some experts argue that with proper precautions, the risks of Martian dust can be managed, but this perspective may be dangerously optimistic. The reality is that space agencies have never before attempted a mission of this duration or complexity. Unlike Apollo missions to the Moon, which lasted only a few days, a crewed mission to Mars would require astronauts to spend months or even years on the planet's surface. The long-term effects of Martian dust exposure are not fully understood, but if it behaves anything like asbestos or silica dust on Earth, the consequences could be severe and irreversible. Furthermore, the ethical implications of exposing astronauts to these hazards cannot be ignored. The risks of space travel are well known, but subjecting astronauts to an environment where they are slowly poisoned by toxic dust over time raises serious questions about the feasibility of deep space exploration. Without a guaranteed method of protection, Sending humans to Mars under these conditions could be seen as reckless, potentially leading to devastating health consequences for those involved. The dream of exploring Mars has captivated humanity for decades, but this new research serves as a stark warning. The red planet is far more hostile than we once believed. The toxic dust is not merely an obstacle. It is a potentially mission-ending hazard that could compromise both astronaut health and spacecraft functionality. If we are to take the goal of human exploration seriously, then addressing this problem must be a top priority. Ignoring it could mean condemning astronauts to a slow and painful fate, trapped millions of miles from home with no way to escape the consequences of their environment. Before humanity can set foot on Mars, we must confront an uncomfortable truth. Survival on the planet may be far more difficult than we ever imagined. The challenge is not just reaching Mars. It is ensuring that those who go can return safely. And unless we find a way to fully neutralize the dangers of Martian dust, the idea of a sustainable human presence on Mars may remain a distant and unattainable dream.